This is a MATLAB generated code simulating an industrial manipulator used to lift faster pucks from the floor to different levels of shelf. As you can see in the code, we have used DH params and different body of links for the robot and a polynomial trajectory to be used for knowing the x and z positions of the end effector in different movements of the manipulator. As we run this program, you can see that there's a dialog box which appears a tab of pickup, shelf 1, shelf 2, shelf 3, and forward kinematic box and inverse kinematic positions. As we press the pickup button, you can see that there is a manipulator being generated as a simulation which is fixed to the ground at one end and has a pickup position at the other end. The pickup position is just above the base of the ground, as you can see, and is depicted in the inverse kinematics in the z direction as 2, and you can see in the graph it shows just below 5. Similarly, if I go to shaft 1, you can see that this has been lifted to another level, which is 19 in the inverse kinematics, and is above the floor just below 20, and a new graph of polynomial trajectory has been generated showing that it is just below 20 in the z direction. Similarly, we have shaft 3 where it shows another position where it has reached a height of 57, and that's the third shelf, and the polynomial trajectory has been created for that to show from 0 to the end effector point. The inverse kinematics is used to know at this particular point at 57 the angles keep changing. That means for inverse kinematics always there is different ways to reach the same end effector point. As you want to see that in a simulation, we need to press the inverse button and we can see a new point of angles being generated here in the forward kinematics, and the point in the z direction remains the same. Thank you for watching this video.